Hello everyone, I am Xiao Gang. In this lesson, we are going to look at this query. This query is actually a large chunk of content. Okay, let's look at the first one. The first one is querying our numerical elements, right? This is quite simple. We can just paste it over. We can write several more so that they can be tested together. Let's still categorize it. I suggest that if you are a beginner, you can follow along with me. Yes, this way should be the best for you. Actually, I know all these things, but every time I use them, I still have to review it in my head. The benefit of doing this is deepening memory. Then increase your proficiency. We use a fixed array. This way, we can declare an array here. We use this initial array so we can get it here. It's number. This empty means nothing. You can see it's just the number Qing Kong, and then this purchase function, it will be executed if necessary. We will emphasize the purchase function in the next sentence. If it is executed, if necessary, we don't have the value, but like the structures after our F stream, it will definitely execute the process, so pay attention to the empty. And as for this one, let's talk about it later when we get to it. These need to be followed by or some knowledge points that come later. Okay, so this place is a numbers. We can query an element within this number. Then you can click into it to take a look. Size type. Let's see what size type is. Size type. This place is the type defined name in logotype. Size type. Let's click further into it. Next. Let me see. You can see this side is here. Oh, it's in this spot. And over here, it's a template. This template, it gets passed into this location using this thing, this size type, and then you'll click on this spot. Later, I can't click there because there are many of them. It should be this one. It should be this container or locker interface size types Intel 1-2. We can look at this class or inside this container. So this size type uses this intersensor. And then, in this place, we should be able to directly use the intersensors this. To connect it, we call it size. We don't need to stop this, because we have already pointed out many things before. It's clearly 5 element. Next, we'll look at this. Then we can use GetData to get the address of its first element. And then, please notice, this location might. If you keep accessing elements further down, this location might go out of bounds. So this GetData, let's call it to take a look. Then at this place, we can see that we zoom in a little here. Zoom in a little. This place returns in stream. It's something like this. Its reference, a pointer of this type. Okay, sometimes you need to get the address of its hand, which looks like this. Then, following this, there is something called a discriminator. There should be another thing. Okay, we can worry about that later. Because we often use a TLV uint8 structure, and then we overwrite a segment of memory. This way, it directly completes the data copy. Instead of using a loop, changing the contents of each object individually like this, this is more complicated, and then you will need to connect many more other instructions. What this means is that you can access it through this hostname, and then use the method of adding this expanded text size to access the other things below. It's roughly like this. You can see that it is accessed through this. It doesn't have a semicolon here. Let's change the semicolon. If you access this, actually, because it is out of bounds, there are only 5. You actually 0, 1, 2, 3, 4. This area is actually also out of bounds. This area is 0, 1, 2, 3. Right, this side should be 3. So we should write it like this. Right, we need to match them up. What does this 5 point to next? We don't really know, because this is restricted. But this way, it won't warn about the restriction. It won't throw an error. If you do this, it will throw an error. Note that we use 5 here. This place will throw an error. It will prompt the boundary. Let's use a bore here. This is from under 5. We just don't know what behavior it will exhibit. Let's use BP0. Okay. How about we do it here? BP0, this BP1, BP. Hello world 012. If this place is 2, we will use 2 here. BP2. We will do it once and finish it. Nia-san. Then we won't have to test it here. We let him add 4. This place is a Sijajaki equivalent of my pointer. Shifting back by 4 bits. After shifting back by 4 bits, we should take a look. It is a pointer, so I should probably use it here. So the behavior should be like this. Okay. Then let's try it now. We might not be able to judge this 5 because it might not be defined. To ensure this, we can give it a placeholder and so on. Okay, that doesn't work either, so we'll leave it here. Okay, this method is through this. By directly accessing this memory, directly first obtaining the address of the host element and then accessing this memory. But sometimes this fails. Why does it fail? If you trigger expansion or reduction of the host, this address of his might change. Only if you don't operate on the host. When changing the host operations, doing it this way is effective. And then note that this area will overwrite. We will go out of bounds again. Okay, now let's execute this rather dangerous method. Apply the fix to the broken link. Okay, one side reported an error. Let's see what error it reports. It's all defined here. Modify this part. Okay, alright. You can see the logs here. They are continuously loading DLs from various sources. We came here, and then this should be find array. Okay, let's execute it now. Good, no problem. For this one, we initialize an array. The array has a total of 5 elements. Then we take the first pointer. The first pointer, it is a string pointer, and it points to this. Hello. Then we got. It looks like this spot was written twice. This doesn't affect. It's the same. And for the first one, there must be some kind of equality. Because they both point to this string, and for the second one, you can see that it is also equal. This is also equal. Then, at this point, it also emits which is false. Because of this location, we can see that if you add 4, it is obviously wrong. If I add 4, it should be pointing at the exclamation mark. We didn't expose it. No need to worry. The one below is out of bounds. Look at this spot. A bait mine was triggered. And then here, we can see this area. this isn't this line of code. Async determination failed. This index, it exceeded. This is equivalent to exceeding our hosts. The number is effectively out of bounds, so this area won't go out of bounds. So, what is this? Actually, this exclamation mark, let's add it. We reference the segment. It makes a copy like this. Okay, so let's add a few more things here for everyone. We do it like this. This is a pointer. We interpret the reference, then we accelerate it. We see if this behavior is defined. It seems that this behavior is not defined. Actually, let's write something like this. Let's take another look at this. These two characters come out. What kind of effect does it have when run? We just want to walk down. We'll go straight to this point. Do you see this string? Hey, it's an exclamation mark. And in this spot, it's just a hey, hello, because it seems like we solved it here. It's solved. So this hello is a string concatenation because it uses this plus sign, this addition operator. And if this place is out of bounds, there's absolutely no problem. This must be the exclamation mark not equal to off, and then there was a problem. These are two ways to access the host. We access it this way. We'll talk about that later. Previously, we accessed the host directly like this memory. If we change the host, this type of access won't work. For example, how do we verify that it is changed host? That's actually quite verifiable. If we do it at this location, if we let it calculate once, we've already verified that they are equal. Here, is that okay? Then let's write another function so we can verify everything properly. We call this place a missed hit. And then we do the same thing. We spawn a host. And then we also first go to access the address of its element. We perform some access to this address. There are definitely no problems with these, but before we execute this, what if we perform an operation like this? We let it open. We pass another host, a different host. We just directly want host 2. We give it a different host. Some. Then we want to guarantee its deduction if. Let's have it add a few more times. By default, they should append everything to it. Let's add it 2 more times. Now, let's take a look at whether the access method below is effective. Meanwhile, let's write another access method. We access the data this way. Note that these two are not the same. Let's separate them a bit. Let's try going this way. How about we call it PC? Okay, let's execute it now. This function segment. Actually, we can just pass it over with just one line of code, but we will try our best to include all these test cases for everyone. This way, it'll be convenient for you to review later. Also, many times, when we need to validate certain knowledge, we usually do this as well. See, this is fine. This is 2 declarations, 2 hosts, right? Then we perform an open on the first host. You will find that its max has reached 28, and this place is 200 in. 42, 34, 23, 45, right? Then let's look at this. Take a look. It is still normal here. This is still normal. This proves that its original address may not have changed. So this is actually normal as well. But you need to pay attention. Meaning, if you modify the things inside, this might cause some problems. Meaning, the entire host's position might change. If the secondary character's address changes, if you try to directly access memory like this, it might become invalid. I think that's what it means. Okay. Next, let's take a look at this part. If the container is a constant, the return pointer is also a constant. So how should we understand this statement? Let's go back. Actually, it's understood like this. We add a const, meaning if it's a constant number, you can use something like this. And then in this part, we give it a const. Okay, then let's say we return it here. We take this thing, right? Then we need to do it like this. If we remove it, you'll notice that it won't compile. It's surrounded by lines. But simultaneously, if we do this, then actually we won't be able to modify it. Then we unreference it. Then we also add the text test. And after connecting the reference, is it a pointer? We let it copy like this. You will find that it doesn't allow doing this. This will cause an error. It won't compile. So if we remove this const, okay, this is not a problem. So let's comment it out. So this const means, it means if it's a constant inside a container, the pointer you return is also a constant. You cannot change it. If you force yourself to change it, you might need to perform some other operations. For example, you can just use a const cost. This is an indication of 1 plus the price. Then how do we inquire about the size of this container element? That is, how big is this thing? Then we can execute this code here. We call it elemental size. Here we call find array elemental size. So we still use this method. We no longer let it enforce the life layer. Let's take a look at both of them. We all use incessor. Let's check with Cessor to see if it works. He seems to be waiting for us to look at the sizeof. What does it return? Defend sizeof. It's the C++ library. It's missing a decimal point. It should be able to perform a type conversion. Let's see what the reason is. We found this place. Actually, this area is useful to compare these two words and determine if they are equal. We won't make a judgment. We can just let it output both of these words. We can add another one here. We can simply write an integer version. Everyone is already very familiar with things like int32. We 234 556. Okay, that's fine. Then let's add an int8 because the ut8 thing is used too often. So let's make another int8. The velocity element here, we can ignore it. We just need to execute this. This segment 3, 4. Let's set a breakpoint. Let's execute it. The error is here, right? Let's check what the cause is. Let's take a look here. I checked it thoroughly. The compilation error should be in this spot. We can't write this const here. We can't write this const here. That will cause a compilation error like this. We should write it here to take a look. This is the usage of const. Let's take a look fast. Can we modify this part? Make a change to it. This doesn't seem to work. We can ignore it. Let's leave it for now. So what I mean is, und.my, if this host is a constant, The pointer that you return is also a constant. Right? Look at this part. It just has const in front of it. Let's look at this part again. You'll notice that it doesn't return an error stream. The function signatures of the two are not exactly the same. You can see that, right? It means this. Okay, we can ignore this part. We should just leave it exposed here. It has nothing to do with the code we wrote below. Okay, let's compile it. The compilation is fine now. Let's start testing this now. Let's test the scale of this. Okay, same thing here. Then we launch. Okay, no breakpoint, set a breakpoint. We launch. This place, after launching, right? Look, its size as 16 elements. Let's take a look at this sizeof. It's also 16, no problem. Proving this structure, it does indeed take up 16 bytes. Right? We can take a look. What exactly is AMI? It takes up 16 bytes. It should be, there is an attribute inside. It's hard to find specifically. We'll just ignore it. We'll discuss this f-street separately later. Let's take another look at this int. As you can see with this int, viewInt center, it returns here. The size of the type is 16. Sorry, I just paused for a moment. Why did it return 16? I went in and took a look. They clearly wrote this. The one for sensor 2 bits, originally it was located here for us. I got it wrong. That really scared me. I said, so it just froze for a moment. Okay. Okay, let's start it again. Okay, if we continue moving down, the 16 here is fine. Then, in this area, it's 4 bytes, right? This is it. It's 16 bytes, and this should be 1 byte. Yes, that scared me to death. Okay, so the problem with this place, it's basically okay. You can see here. I clearly told you about this spot. It's a platform dependency. It should be 8-bit. 16-bit, 32-bit, 64-bit. This one is the same too. And these are strings for various platforms. We'll put them in strings because of this place. Designed into a conversion. This conversion is very important because when we are doing network transmission, when we connect and interact with the server, when we communicate, we usually use this UTF-8 encoding, but sometimes you might encounter strange problems. It's possible that you will run into GBGA encoding or const NC encoding, right? There are some other situations, but what we commonly use is UTF-8. Okay, we will stop this lesson here. Thank you, everyone.